So, hi, good morning. Welcome to this another series lecture about basic electrical theories. Now, on the previous lectures, we discussed what is voltage, current, resistance. We also discussed the Ohm's law, the relationship between the voltage, current, and resistance in a mathematical expression. And then in the last lecture, we discussed some properties about series circuits. Now, in this particular lecture, we are going to discuss parallel circuits. These parallel circuits is very, very important because this is widely used in our electrical appliances, electrical applications. Now, let's proceed with our discussion here. So, parallel circuits. Okay, so how are we going to identify if that particular circuit is connected in parallel? So, very, very simple. Again, if you have two loads here, okay, since these particular loads have two terminal load, okay, terminal 1 and then terminal 2, we can say that these two loads are connected in parallel if the two terminals are connected with each other. So in this particular case here, that one is connected, and then this one is also connected to the other terminal, so that is connected in parallel. And then if we're going to connect this one with the voltage source here, which is also a two-terminal device, so these three things here are connected in parallel. Okay, so let's try to rewrite this one here. Okay, let's try to rewrite this one. Make it a little bit better. Okay, so let's say the voltage, let's say we have a voltage source here, let's say, okay, voltage source, or commonly, because the common application of the voltage here are in an AC format. So let's have an AC here, okay, and then we have some loads here. Okay. So we call this one as the voltage source, and then we call this one as the R1, same with the previous example, and then let's call this one as the R2. Okay. So now let's try to examine the properties of these parallel circuits with respect again to the voltage, current, resistance, and then the power, as what we did in the previous lecture. So first is we have to discuss. So we have here the properties. So let's start with voltage. So the voltage here in this particular case here, as what we can see, we have Vs, okay, which is the voltage source, voltage across that particular source. And then if we're going to connect our multi-tester here, okay, and then connect this particular case here, okay, and then the value that we are going to get is what we call the voltage 1 or the V1. Okay, and then in this particular case here, we're going to connect a voltmeter again, connect and then measure the voltage. You are going to get the voltage which is equivalent to V2. Okay, so what's the relationship of the Vs, V1, and V2 with respect to parallel circuits? So in parallel circuits, the voltage are the same. Okay, if we're going to write that one mathematically, so that is the voltage source is equal to V1, which is equal voltage to V2. Okay, so the voltage of the loads are the same with the voltage of the supply. Okay, this is similar to the series. So sa series, the currents in the load and in the supply and then the loads are the same. However, in parallel circuit, the voltage are the same. Okay, and then how about the current? So we have three currents here. Okay, so we have the current flowing through our source. Okay, throwing to our source and then connecting to this node here. We call this one as an electrical node. Okay, and then inside this electrical node here, so this is the I source. We can call this one as I source. And then we have a current flowing through our R1. So we call this one as I1. Okay, and then there is also a current flowing through this branch here, which is supplying towards the R2 here. So it means that there is a current here. We call this one as I2. Okay, so in this particular case here, the relationship of your IS with respect to your I1 and R2, I2 is additive. Okay, Okay. So this one is equal to the I1 plus the I2. So that's the relationship. IS is equal to I1 plus the I2. Now, let's talk about the resistance. So the resistance R1 and R2, again, if you're going to, before you're going to measure the R total of this particular circuit, you have to remove first the voltage supply. So in this particular case here, if you're going to rewrite this one, it should be here. You have the R1 and then you have the R2. So if you are going to measure the resistance, the total resistance in a parallel circuit, connect the resistance there, the multimeter, so the R total is equal to like that. So in order to solve mathematically, the R total for this in a parallel circuit, the formula is equal to, okay, 1 over the R total is equal to 1 over R1 plus 1 over R2. Or if you only have two resistors or two resistance in a particular circuit, and then you're going to solve for the R2, R total, we can also use this formula here. The R total is equal to R1 multiplied by R2, okay, divided by R1 plus R2. So this is the formula here. And then for the power for this particular circuit here, since we have a power supply, so this is the power source, okay, and then we also have the power for power dissipation in our R1, and then we also have here in R2. Okay, take note again, based on my discussion on the previous lecture, the power are always additive. So in this particular case here, the power source is equal to the P1 plus P2. Okay, this is for power, and then this is for the resistance. Okay, so before we proceed with sample problems, okay, let's try to have some simple problems first relating to parallel discussion. Okay, and after this lecture, in the next succeeding lectures, we are going to solve problems which is very, very similar to the things that will come out in your written assessment. Okay, so let's try to solve some problem here. Okay, so given, let's say we have a load here, a power source, a voltage source, and then okay, we have this one is the R1, the R2, and then this is the voltage source. Okay, so let's say we have 100 volts, and then the R1, let's say 40 ohms, and then the R2, let's say 60 ohms. Okay, so first is solve the following or find the following. Okay, you have to find, let's say, the R total, I total, C. We have to find the I1, D. You have to find the I2. Or you can also, let's say, let's add this one. Try to find the V1 and then the V2. Okay. So in this particular case here, let's try to solve for the R total. Since we only have two resistance in this particular problem, we can solve the formula using R total is equal to R1 times R2 divided by R1 plus R2. So, sir, what if there are three resistance in that particular circuit? So you are going to use this formula here. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So that's the basic formula for solving, so on and so forth. Okay, so in this particular case here, let's solve this one. So the R1 is 40 ohms, the R2 is 60, divided by 40 plus 60, so that is 100. So use your calculator. 40 times 60 equals, divided by 100, 24. So this is equal to 24 ohms. So that is our R total. Now, let's solve the I total. So the I total, again, if we're going to use this one, V IR, and then if we're going to find the current in this particular case here, so you just have to put your finger in the I. So as what we can see here, to get the I, we just have to divide the voltage and then the resistance. Oops. Okay, so we have to divide the voltage and then the resistance. But in this particular case here, since we are interested in finding the total, the I total, we have to put some total here and then put some total here. Okay, so the V total in this particular case here is 100 volts. Okay, and then the R total is equal to 24 ohms. Okay, so we just have to divide that one, 100 divided by 24, so that is 4.17. 4.17. So that is equal to 4.17 ampere. That is the I total. So it means that that is the current flowing through here. So that is the I total. Okay, now, so let's try to find the I1. Okay, the I1 and the I2. So there are other ways how to solve this one, but the easiest way is we're going to follow what we've done in the previous, in this letter B. So I is equal to V over R. Since we are interested in finding the I1, so it should be, this one should be V1, and then this one should be R1. Okay? And then take note, in this letter E here, take note the V1 and the V2, since this is connected in parallel, so the Vs is equal to the V1, which is equal to the V2, equals na yan. So it means that we can directly solve this one, which is equal to 100 volts. Okay? So the V1 here is equal to 100 volts. And then the R1, let's say 40 ohms. So just divide 100 divided by 40. 100 divided by 40, 2.5 amperes. So let's put some value here, 4.17 ampere. And then this one here is 2.5 ampere. Okay. Just have to find that another, the I2 there. So the I2 is equal to same, VIR, but we are interested in finding the 2. So 2, and then 2, then 2. The V2 again is same because this is connected in parallel. So 100 volts divided by the R total in this particular case here is 60 ohms. Okay, so again, use your calculator. 100 divided by 60. So that is 1.67. 1.67 amperes. So this is equal to 1.67 amperes. Now, let's try to observe this one. As what we can see in the previous discussion, we can also solve for the I total. The I total is equal to I1 plus I2 in a parallel circuit. Okay? So take note, the I1 is equal to 2.5 plus the I2 is equal to 1.67 amperes. Okay? So the I total here is equal to 4.17 amperes, which is similar to what we got in this previous solved problem, which is letter B. Okay? So that's it. In the next lecture, we are going to solve series of problems, okay, which is very similar to what will come out in your written assessment. Okay, so see you in the next